Hello students, in the last session we have seen what do you mean by packing efficiency. Also we have seen what is the packing efficiency if the unit cell is simple cubic unit cell and the cubic unit cell is body centered cubic unit cell. Today what are we going to study? In today's session we are going to study how to calculate number of particles present in the given mass of an element or number of unit cells present in the given mass of a particular substance. So in today's session we are studying number of particles and unit cell in x grams of metallic crystals. Okay. The number of particles and the number of unit cell in the given mass of a metal can be calculated from the parameters of unit cell. Which are these parameters? The parameters are number of particles per unit cell. Let us call it as n. If the unit cell is cubic, the value of n will be 1. If the unit cell is body centered, the value of n will be 2, and if it is face centered, then the unit or the value of n will be 4. The second parameter is volume of unit cell. How do you find it out? Using the formula A cube, that is edge length cube. So if I know the number of particles per unit cell and edge length of the unit cell, then I can find out exactly how many number of particles and how many number of unit cells are present in the given mass of that particular metal. We also know that density rho, molar mass m are related to each other with the help of the above two parameters as. This formula we have derived. M, which is molar mass, is equal to rho, that is density, into A cube, that is edge length cube, into Na, Avogadro's number, upon N, that is number of particles per unit cell. Then, now let us see how to find out number of particles in x grams of a metal. We know that molar mass M contains Avogadro's number of particles. So if I take n grams of a metal, then the number of particles are Avogadro's number. Then x grams of a metal, how many particles are there? So in x grams of a metal, x into Na upon m, these many particles are present. Now what I do is, I substitute for m here, because if molar mass is not known, then these parameters can give me the number of particles. So substituting for n, I get in x grams of a metal, the number of particles are x into small n upon rho into A cube. Now let us see how to find out the number of unit cells present in x grams of a metal. We know that in one unit cell there are n particles, means if I have n particles, they correspond to one unit cell. But in the third step, we have calculated number of particles as x into n upon rho into A cube. Then these many particles corresponds to how many unit cell? Just by cross multiplying and cancelling n, you get x upon rho into A cube unit cells. So, number of unit cells in x grams of a metal is x upon rho into A cube. So, these are the number of unit cells and particles in the given mass of a metal. Given mass of metal is x grams. But now, number of unit cells in the volume V of the metal will be V upon A cube. And let us take a simple problem based on this concept. See the problem. There is an element niobium. It forms BCC structure. The density of niobium is given to be 8.55 grams per centimeter cube. The edge length is given to be 330.6 picometer. I want to find out how many atoms and unit cells are present in 0.5 grams of niobium. First, let us understand the data given in the problem. Niobium structure is BCC, body centered cubic. So number of particles per unit cell, small n, will be 2. Mass of niobium, X, is given to be 0.5 grams. Density, it is given to be 8.55 grams per centimeter cube. See the unit of density, it is grams per centimeter cube. So if density is in grams per centimeter cube, then mass should be in grams. Fortunately, mass is given in grams, so no problem, no conversion. And volume should be in terms of centimeter cube, or edge length should be in terms of centimeter. But unfortunately, edge length is given to be 330.6 picometer. So I need to convert it. I have to multiply by 10 raised to minus 10 to get picometer into centimeter. So by multiplying 10 raised to minus 10, I get 3.306 into 10 raised to minus 8 centimeters. Now I want to find out number of atoms and the number of unit cell. So the formula that I am going to use is number of particles in x grams of a metal is x into n upon rho into a cube, and number of unit cells in x grams of the metal is x upon rho into a cube. So first, let us find out how many particles are present. Number of particles in x grams of a metal is x into n upon rho into a cube. So number of particles in 0.5 grams of niobium is, now I will substitute here, instead of x, 0.5, instead of n, 2, for rho 8.55, and for a cube 3.306 into 10 raised to minus 8 the whole cube. After calculating it, the answer comes out to be 3.25 into 10 raised to 21. So the number of atoms in 0.5 grams of niobium is 3.25 into 10 raised to 21 atoms. Now let us calculate number of unit cells. Number of unit cells in x grams of a metal is x upon rho into a cube. So number of unit cells in 0.5 grams of niobium is, I will substitute these values. The value of x is 0.5. The value of rho is 8.55 into a cube will be 3.306 into 10 raised to minus 8 cube. So after doing the calculation, you get the answer 1.62 into 10 raised to 21. So in 0.5 grams of niobium, the number of unit cells are 1.62 into 10 raised to 21. So the final answer of the problem is number of atoms of niobium are 3.25 into 10 raised to 21, and number of unit cells are 1.62 into 10 raised to 21 in 0.5 grams of niobium.
Thank you. Please like, comment and subscribe for the further videos.